Unit 9, the final unit. It's hybrid and EV HVAC technology, and this is going to have a bit of overlap with normal vehicles too. But it's mostly focused on newer stuff, evolving things, emerging things. Cool. So when we get into hybrid and EV, anything electrified, I'm going to use this a couple different terms in the presentation. So if it's electrified, that probably means it's either hybrid or EV, and if it's BEV, that's battery electric vehicle. You know, a lot of terms, but generally they're going to be an automatic climate controlled HVAC system. So that means you can press the auto button, it'll heat, it'll cool, it'll recirculate, it'll fresh air, it'll do everything automatically. Um, and and partially that's because this right here. There are additional demands put on the HVAC system by the hybrid vehicle. So as we get a little bit further in, we're going to look into like range, especially with a battery electric vehicle. We really are concerned about range. And if the customer's not really managing the air conditioning well, it can reduce the range. I mean, even managing it well is going to reduce the range, but it can reduce the range excessively. And then you've got a customer in the dealership saying, my vehicle doesn't get the miles it claimed to have gotten, and the technician's trying to figure it out, and there's nothing wrong except, that customer is putting the AC on full blast and then putting the windows down. That's going to cost you, right? So with these automatic systems, it's going to look at a number of different inputs and determine, how it can most effectively and efficiently make the customer, the driver, the guest, if you will, feel comfortable, right? But we're overriding the bad decisions of the consumer right there. Okay. And then additionally, we got a battery, and the battery on these vehicles tends to be either in the trunk or under the seat or sometimes in the floor. And we need to manage the heat or the coldness of that battery, right? So as soon as we're into those hybrid and EVs, the HVAC system's going to be fairly complex. The cool thing is it's not, it's nothing really new. It's improved, it's slightly changed, but it's the same type of air conditioning system as a regular car. And that's the reason that it lands well right at the end. By this point, you should be fairly familiar with a lot of the technologies, and we're just going to be upping it to the next level. Okay. So like for example, it may need to provide cooling either directly or indirectly to the high voltage battery to prevent it from overheating, or also to prevent it from getting too cold. Okay. And then again, like there's several benefits of a hybrid vehicle AC, but one of them would be you can actually start the cooling process before you're even in the vehicle. So this was like the original remote AC system. You could actually press the AC button. It wouldn't start the engine, but it would start up the electric AC compressor, start pumping and circulating the refrigerant, doing the evaporation in the evaporator, the condensation in the condenser, and you could have a nice cool cabin. So hybrids I know are not real, people aren't real enthusiastic about them. They're not necessarily the most high performance vehicles, and they're not the most beautiful vehicles, but I'm going to tell you, it's pretty nice when you can remotely activate your air conditioning before you even get out to the car and have it nice and cold, so starting to sell you on some of the positives. Now, this is true for EVs as well. All right. So one of the things you got to understand that's so different on the hybrid, the compressor may be driven by the ICE, but that's like the old school hybrid. Um, Most of them are going to be a high voltage electric compressor motor, and that it has no belt, it has no clutch, it has no pulley, it doesn't need those types of things. Um, the cool thing is, if, like I said, if we drive it electrically, that means we can run the AC compressor without the engine running. So now you get into a whole bunch of positives. So, if you have a vehicle that's doing a lot of stop and go traffic or doing a lot of idling, or, for example, if somebody's trying to do Uber or even Uber Eats, it's much more manageable to keep these cars cool without burning a ton of gas, leaving the engine running all day, every day, right? So if you were to have to stop and pick up the Uber ride, you know, your Uber customer, whatever you call them, the Uber user, you know, you got to have that car cool by the time they get in. You can't get in and then start it and then have the AC cool down over the next 5 minutes. It needs to be cool as soon as they get in. If you want to get a good review, no problem. The AC can run and the ICE, the internal combustion engine, can shut down. Boom. Keep it cold, keep it cool, because it's driven by that electric compressor. But you notice it's high voltage, which means that's pulling from the high voltage battery, and that can typically run the compressor for hours, if not days. Make sense? All right, cool. And sometimes they have dual drive. That would be a little more rare. The compressors aren't really all that different. It could be a scroll type. That's probably the more common. But if it's a scroll, all the compressor parts are the same as we covered AC compressors. However, there's no pulley on the shaft. The shaft goes to an electric motor, right? So this being the scroll is being driven by this electric motor. So here we have, you know, the rotor and the stator, the armature, and we'll just call it the electric drive. And we could go pretty in detail on these if we want, but I'll keep it fairly simple. As soon as we get into this type, it's either going to be one of two things. It's going to be a DC driven or it's going to be an AC driven. Um, Ultimately, they're all probably going to be AC driven, and that's going to be a three phase. So let's start with that. Three phase is going to have three big orange wires coming from the inverter. And I debated how involved I wanted to get on the three phase AC. And if I go really in detail, this is going to be a three phase AC presentation. So I'm going to keep it very simple. The three phases of AC come from the inverter, U, V, and W, and they will drive that motor. So the part that controls that compressor is the hybrid inverter. The big inverter has a section where it'll actually control the compressor. Now, because it's a three-phase AC, we can speed it up, we can slow it down, we can do all these types of things, and it's already being controlled, computer controlled, right? So in that system, you've got the HVAC ECU looking at the demands and communicating with the hybrid ECU, and the hybrid ECU telling the inverter, hey, send more, you know, more RPM, less RPM, etc. Now, if you run back to compressors like several units ago, we talked about the variable displacement, right? How we can have it stroke full or none or half or whatever. We don't need variable displacement because this compressor, we can vary its speed independently. We don't need to have the engine running. There's no need for the engine, right? We can have it run slow. We can speed it up. Right. So these are inherently kind of like more efficient because they're sort of like a variable displacement. It's just we're changing the speed. Cool. Now that's if it's AC driven, right? 3 wires for AC driven. The wires U, V, and W are orange. Just we're going to come back to that. If it's a DC driven, which is fairly common, um, that means that we're going to send 2 wires down there, positive and negative, but inside of that compressor, there's going to be a little mini inverter, and that's going to invert it to 3-phase AC. All right. So kind of doesn't really matter other than, you know, if you have a fault with one of these compressors, you need to either verify the 3 phases of AC are getting there, which is a whole side discussion. Really, we'll save that for hybrid vehicles because the way we test these is pretty much the way we test the transaxle. The transaxle, like MG1, for example, has U, V, and W. And we could do like insulation test using the mega ohm meter. We could do windings test using the milliohm meter, checking the internal resistance, right? So these are terms that are best covered in transmissions. So if you really need to know a ton about it, flip over to transmissions and look at the hybrid drive systems, because actually it's pretty much the same, right? So if that's three phase, cool. Now, if it's DC, there's just a positive and negative going to it, and then it has its own inverter. So let's just say this compressor is defective. It's not working. We would just need to make sure it's getting the DC right there. So if it's supposed to be getting 240 volts DC, you would measure 240 volts. Now, how? Because we don't normally measure that with the hybrid system up, and these cables are sealed, and so you can't really back probe them. But there are ways. There are safe ways to do it, and um, hybrid vehicles. Let's save it for that. Cool. So if you look at something like this, we can have multiple different types, but this one is a dual drive. This can be electrically driven or belt driven, and that's not real common anymore. Now, to make the point, if it's hybrid vehicle, orange colored wires, right? We can't just start poking around on those. You don't test those in the same way, right? So you need to really be, as soon as it's hybrid electric driven compressor, you're really closely following service info. So typically, like if we jump into this one, if we had a fault with the electric compressor, a lot of times those are setting codes. So we're doing more DTC diagnosis. If we had a loss of isolation, we would usually power the system down, glove up, remove the service plug, verify the voltage is zero out of the battery, and then we can safely disconnect and do some testing on the electric compressor. So a lot of times when we're doing these tests, it's not live. We may do insulation tests and whatnot, but you're never just winging it. You're never just like, oh, let me just diagnose it. The way we diagnose these, you really need to be closely following the service manual, which is good. I mean, that's kind of what we should be doing on all of them. But with these, it's especially critical. Cool. So simple. If you think you got an issue with an electric compressor, you're most likely going to have a DTC. You're going to use that DTC, go into service information, and kind of follow the steps, right? So I'll even pull one up as an example. All right, but additionally, we've got the compressor, but what controls and drives the compressor is the inverter. And so the inverter has dedicated portions that are really like compressor drive. All right. And then also we got a lot of times a coolant pump, like a water pump. Sometimes we can use that water pump to circulate coolant as well. So when we start looking into these heating systems, just remember, if it's a hybrid, the engine still makes excessive heat, and we can use an electric water pump to pump that coolant into the heater core. However, sometimes that's not, like with a battery electric vehicle, there's no engine. So we're not going to do that. We're actually going to use the AC system for both cooling and for heat. And that's when we get into heat pumps, which we will discuss. Okay. Then of course we got the interior HVAC box. It's not very different. But the heater core has a PTC heater on it. So what that means, that's like an electro-resistive heating element. So if you have your hybrid and you start it up, and there's several designs, right? So this is an example. If you have your hybrid and you ready on, but the engine doesn't start, but it's cold outside, you need to have heat. We'll actually run that PTC heater either as the sole source, or if the engine does start, those hybrids can take a little bit of time to actually generate a lot of heat. This PTC heater can help heat the heater core up until the coolant's actually hot enough by itself, right? So we'll start to do like electric heating and engine coolant heating. Now, if it's a battery electric vehicle, there's none of that. There's no reason to do it that way. We'll do several other forms of heating. Okay, and we'll come to those. And then again, it's got the AC ECU, but that's no different than the electrified AC systems, like computerized AC systems. Okay, cool. So again, with that AC compressor, electrically driven, high voltage, generates the high and the low, cools the cabin, can operate independently of the ice. So if you look at this picture right here, that looks like an AC compressor with a random cap on it and no pulley. Yeah, that's what it looks like. It's got the high line, the low line. This one actually has a little mini inverter right here. And so this is a design that's going to be DC. It's going to send a positive and a negative down, and this is going to generate the three phases of AC all internal. Not a real big deal. And so if you were to look at it, this one is going to do DC 201 to 288. Now that depends on the battery pack voltage. Then from there, the AC inverter that's bolted onto the compressor is going to invert it DC to AC, and then it's going to run three-phase AC brushless motor. Cool. That's its design. Now, what controls the compressor speed? You guys tell me. Engine RPM? No. No. Computer. So the ECU is going to look at the demands, right? We don't want to drive the compressor any more than we need to because, again, a hybrid's all about efficiency. And an electric vehicle, we're really concerned about range. So we only want to drive that compressor as much as we need to. We don't want that compressor going at full speed and just wasting energy, right? Efficiency. Cool. So that's a nice part. Scroll type is pretty typical. All right. Oh, and by the way, these use ND11 compressor oil. And we'll cover it one more time, but anybody have an idea why the compressor oil would be so different on this? I mean, this system could be R134A. It could use a PAG oil. PAG oil works great with R134A, but PAG oil is not good for an electric compressor. And similar, if it's R1234YF, we have PAG oil that's specific for YF. But this is the thing. You have the compressor parts right here and the coolants and the refrigerant circulating, and this electric brushless motor is right there and often exposed electrically to the refrigerant and the circulation, and it's really a lot of it's going to be together. So whatever oil is in the system has a chance to potentially make a connection between one of these coils, this phase, right? Remember the phases are U, V, W. If this is phase U, this has high voltage in it. We can't have the high voltage conduct through the oil to this housing. Because if you notice, this housing, it's bolted onto the engine block, which is grounded. On this hybrid system, we need what's called isolation. We need U and V and W going directly to the compressor, and that's it. We can't have U or V and U, V, or W have any sort of a path to chassis ground. And I like, without getting into AC all crazy, I always like to point that out because when you look at the three wires, if this is a 3-wire compressor without the inverter, you're like, which one's the ground? It's alternating current. There is no ground. While phase U is positive, W is negative. So it's alternating, right? U being AC will be positive, and then it'll be negative, and then it'll be positive, right? Alternating current, if you'll remember. So it doesn't have a ground. It doesn't need a ground. There is no ground. There's just a ground's not a thing. All right. So each one of those is the positive and the negative, depending on where it's at in its phase. And we're going to have three of them, right? So now if it's this type, which is a DC, which then internally will invert it to AC, that's going to have a positive and a negative. Yes, I agree. All right. So a little bit weird. None of those positives or negatives or ACs, none of them can have any connection to the chassis ground. Those high voltages must be isolated. So if we put the wrong oil in this compressor, like a regular PAG oil, it's a little more conductive to like electricity. So you may find your high voltage conducting through the oil to the ground, and that'll actually set a fault in the hybrid system called a loss of isolation. And if you get a loss of isolation fault, you get a little triangle with an exclamation mark, and the car won't ready on and it will no longer drive. Now, that won't typically happen while driving. That'll usually happen on the next startup. right? So if it gets a loss of isolation while driving, a lot of times you can finish the drive. And then on the next one, if that fault's still there, you're done. All right. So the reason I like to bring that up is it may be on the ASE, but it's also very critical. You must use the correct type of oil on a hybrid or EV. There's conductivity issues. So the horror story that, goes around is car came into the dealer for AC blows warm. Technician went ahead, did the whole AC service, right? Recover, vacuum, injected the oil, charged it, performance tested it, worked good, gave it to the customer. Customer took it home. Next morning, it wouldn't ready on. They towed it back and they were like, it's a problem with this. Maybe it's the wires. Maybe it's the harness. Maybe it's the battery. Maybe it's the inverter. Maybe. And come to find out it was because the tech worked on it, didn't use the ND11, didn't use the ND11 hybrid and AC, hybrid and EV specific oil. Okay. That oil caused that car to get towed back in. Cool. All right. You got it. All right. Let me pause right there for a quick moment because I want to just the goal is to show you some things, but additionally, I want you to understand not only be exposed to the technology, but just not be intimidated by the diagnosis, right? If a car comes in, I don't want you to be like, oh, I'm nervous because it's a hybrid. It's not a big deal. TIS, all right, let's go with your favorite hybrid of all time. Let's do a Prius. Matter of fact, we'll do a Prius Prime. It's a big ballin'. All right, let's make it like a 2019, right? So it's not even really that new. And let's do compressor. And we'll just skim. Like if I jump right in here, it'll talk about compressor removal, installation, no biggie, disconnect. Oh, orange wire harnesses. Wait, don't die, dude. And then it's going to say, hey, follow this, click this first, recover the refrigerant, remove the service grip. All right. You'd stop. You'd be like, remove the service grip. Wait a minute. It's going to walk you through how long? How long do we wait? What do we wait for? What do we do? What do we do? Remove where it's at, where the panels are. Right. So when you go to this, you don't have to memorize it. You have to be able to reference the information. So right here, you don't just skip this. Right? I kind of skipped it. But one of the first steps is to go in the vehicle, do a health check for codes. DTC P0AA649 is isolation internal electronic failure, or any of these other DTCs. If any of these DTCs are set, you don't work on it yet. You got to troubleshoot those first. That's basically telling you may have a short from the high voltage to the chassis ground. That's what it's saying. That needs to get taken care of. Now, like I said, using the incorrect oil could cause one of those. See, so it gets a little tricky, but you're going to follow all this. It's nothing crazy. You just have to have the information, right? Then when we do the inspection, you'll notice, oh, that's the service plug grip. I want to get out of that. The service plug grip is not real complex, right? Alrighty, I think we're off a service plug grip. Okay, but when we are remove the service grip, check the terminal voltage, that's going to have us remove the cover for the inverter to make sure there's no voltage coming out of the battery. We're just guaranteeing that the system is safe, and then we can actually remove our gloves, right? So once you verify there's no high voltage outside of the battery, you're good. You don't have to wear the goofy mittens. You can get down to business, but you'd be following this. And so, you'll follow, right? It'll show you more and more and more, do this, do this, do this. And look, this isn't that different. I mean, there's a lot of steps, but it's basically like we're doing the same type of work with a couple extra precautionary measures. Cool. Says to remove it. Sometimes the connector locks are different. So this may actually need a screwdriver to undo this connector lock. And that's the reason for that is they don't want someone accidentally undoing that. And when you undo this, they do call to wear insulated gloves. So I'm not really in a good position to tell you not to, but bluntly, right, as not just a person who teaches the class on it, as someone who works on this stuff too, if you've done the whole safe procedure and you've measured that there's no high voltage coming out of the battery, you don't have anything to worry about right here. Cool. But in an abundance of caution, TIS is calling out wear insulated gloves. All right, cool. And that's just when you're doing the disconnect. It's not saying you must wear insulated gloves to get the 10 millimeter bolt out, right? It's talking about when you do the disconnect, just as an abundance of caution, which is probably unnecessary. Um, go ahead and wear the insulated gloves. And then look, we're just unbolting it. We're bolting it back up. It's not even a big deal. And a secret trick, if you can't get the compressor off because the studs are there, you use an E8 Torx and you can pull the studs out. This actually tells me that they did talk with a technician on this. This wasn't just written by the engineers. All right, cool. And then in installation, you're going to notice it's not a real biggie. It's saying, use new compressors. I mean, use new O-rings, the bolts, the connections, wear the gloves, keep it clean, bolt it up, and then you're going to charge it, warm it up, inspect for leaks, right? It's really not a big deal on any of that. Right? It's fairly straightforward. Cool. So if you were to consider that, that one's good. The thing I did want to do was take a look at this real quick. If we had, again, if we had fault codes, let me have a quick peek here. They can actually set codes for refrigerant low or for high. So let's say we don't care about the low pressure mag valves. We got expansion valve issues. Let's see. Let's see. Well, we could actually go with how to proceed with troubleshooting. Cool. We could do some basic analysis. Yeah, not much there. I know there's going to be DTCs. I was looking for maybe a isolation fault inverter. All right, not a communication fault. You don't want to lost communication with the heat pump unit. Those are all communications. All right, how about this? Well, this in general is talking about if you run the test, compressor operates, but cooling effectiveness is poor. So if it's not building enough high pressure or low pressure, it just has you do a couple basic checks. You can do an active test. Um, and you're just basically gonna look at these temperatures, follow, right? So you're never just winging it. Make sense? And you don't just go by the gauges. And that's where it's slightly different. Like with this, you don't know exactly what the inverter is commanding the compressor to do. So if it's a belt driven compressor and you look and you see that it's running and you look at the gauges and the gauges are the high is not high enough and the low is not low enough, you're like, oh, the compressor's weak, right? With this, you need to really go through and it's going to call out to do some various tests, right? And so you can see it's not really a big deal, but you're going to follow along with these tests. And a lot of times it's going to be DTC based. All right. So none of this is a really big deal. None of this should be a very big deal to you. All right. And so from there, we'll jump back in. Hopefully that was helpful. And I'm even going to close that, minimize that one. Right. So nothing to be scared of. Then when we get into the hybrid heating system, like I was saying, you have a heater core here, but this heater core actually has heating elements and electrodes in it. So, sometimes they were integrated, other times they snap on the side and go along the fins, right? But on a lot of them, they're going to have some form of a PTC electric heater. So you can see there's some electrical connections, and this is going to actually warm this on the hybrids while the engine might not or may not have started. We can still get some heat. And then a lot of times the circulation will be done by electric water pump. So these electric water pumps are typically low voltage, 12 volts, source voltage system. So we diagnose this. You might as well be diagnosing a windshield washer motor. It's not real big. Now, sometimes these can be, if it's an engine water pump, they can be bigger. They can have a heat sink, and these can be three-phase AC, a little more complicated, right? But sometimes they're basic DC circulation pumps, and other times, and if it's got this basic circulation pump, it's going to have a mechanically driven water pump. But if it's got an electric water pump rather than an engine-driven water pump, that's going to be like probably a DC, much higher performing motor. All right, cool. And then when we get into the temperature control system, it's not that different. You got the steering wheel, where we can push buttons, which will communicate to the ECU, AC ECU. We got the multi-display, which you can push the LCD screen, which is kind of like buttons, which is on a communication network, right? So you pressing buttons right here, if you want to know if these buttons work, you go in the text stream and you go to the multi-display and you can actually see what you're pressing. Then that's going to send a signal through LAN, local area network, to the gateway. The gateway is a communication, like a multilingual communicator translator, and says, you know what, the gateway speaks LAN, and it's going to basically take that information and process it to another type of network communication protocol, Bean. And Bean is like a little slower. It's a lower priority, right? So it's just saying, like, through Bean, the AC ECU can know what the multi-display requested. It can change the give signals to the meter, and the meter can change what's shown on the combination meter and can communicate back to the AC ECU. And it's just networked, just really not that different than what we could talked about last time, right? And so it's essentially um, computerized AC controls, just with an electric driven compressor. Not even a real big deal. If you look, all this is the same, except the AC ECU doesn't control the compressor. The AC ECU sends a signal to the high voltage ECU, which sends a signal to the AC inverter, which actually controls the electric driven compressor. All right, so the AC inverter can be on the compressor on the 2-wire DC unit, or it can be in the inverter and then send the 3-phase AC to control the compressor. It's not, I guess, not really critical information, but just so you're familiar, you may see some with 2 wires and you may see some with 3. Now you know it's either got the inverter in the compressor or it's got the inverter in the inverter, but it's an AC inverter. So we call it the inverter, but really the inverter has multiple inverters and converters in it, right? The big inverter under the hood does a lot of stuff. Cool. And you may or may not be able to get the AC inverter separate. So that's why it is kind of nice when the AC inverter is built into the compressor. So at least you're not buying like a whole big hybrid inverter for a AC problem. Cool. So this should be fairly familiar to you, right? This should look familiar. Now, we're going to come back to this a couple times, actually, because I want you just to remember this is the AC system. Now, when we get into battery electric vehicles, it's very, very important that we are efficient. We need to be efficient. We need to maximize it, because remember, we've only got so much battery power, right? If it's a typical BZ4X, RZ450E, a lot of the Tesla models, the Mach-E, a lot of them are running right around 100 kilowatt hour battery pack. That's it. You got 100,000 watts. And that's if it's charged to the max. And then that's discharged to the safe number, to the that you never discharge it to zero. You can't. You're talking thermal runaway and all sorts of issues. But right? You got a limited amount. You can't just gas and go, right? So these are some of the reasons why people are hesitant to get a BEV, a battery electric vehicle. One of the factors is climate control. So if you're using a lot of AC, that's going to draw big time on that battery. It's the same. Some of you are pretty young, so you don't really understand this yet, but you'll know. Your electric bill is severely changed based on what you're doing with that AC, right? So like if you ever want to get into it, you can get a copy of your electric bill. You blast the AC and you make yourself feel really comfortable, you will see a massive increase in your electric bill. So cooling a cabin, cooling a room, cooling a home, like it's not a small thing. That's going to take some energy. However, it's the most efficient way that we really have to actually remove heat. And we're trying to make it as efficient as possible. And there's different efficiencies, and we'll get into some of the tech to increase the efficiency here. But on a battery, this is critical, 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 because it's not that your electric bill is going to go up; it's that you may not make it to your destination. Make sense? So a lot of these systems are tied in where if you're running low on range, and especially if you have it GPS, it may say like, hey, you're not going to make this unless you chill on the AC. And it'll a lot of times put it into like a mode where it's not letting you get the full effect of the AC. It's going to limit the compressor performance. Cool. But if you overuse it, can reduce the range, right? So that's when we get into that. Um, the next thing here, we could go into a ton of detail, but I want to give you an overview. And actually, again, the best way to really deal with a heat pump is you get a heat pump issue, you're going to have your head buried right in service info. All right. But when we talk about the BEV, the AC system, I said, is the most efficient we have, right? AC's costly, but it's the most efficient way. It's really the only way to do cooling. But when you get into heat, these battery electric vehicles, they need heat as well. There's no engine, right? So some we'll come back to a little bit later. If there's no engine on a battery electric vehicle, how do we make heat? Well, one of the answers is the heat pump. So this looks like an AC compressor, and I would still call it an AC compressor, but technically this is a heat pump. It's the pump for the heat. Like what? All right, check it out. It compresses refrigerant, provides pressure to a state change device. State change device causes a temperature differential, directing hot side extracts direct heat into the cabin. So say what? It's 1.5 times COP. So when we get into uh, productivity or efficiency numbers, it's quite a bit more efficient. All right. And the heat pump can actually have COP of 3 to 4. So just pause right there. What does that have to do with this? All right. I'm gonna give you just like a basic overview. Then I want to show you a manufacturer's page. So if you want to talk about efficiency, one of the ways we could make heat is electroresistive. So you can literally use electricity to make heat, right? Like back here when we were on the PTC heater. That's a way to do it. And it's fast. And honestly, it makes sense for a battery electric vehicle because you have a ton of power right there. Just heat up a heater core and then you'll have heat. But this is the thing. It's very inefficient, electroresistive heating. So instead, we start looking at this, right? If we have this electric driven, we can compress high side, make the condenser do the condensation, which when it goes from a vapor to a liquid, that's going to reject a bunch of heat, right? It's going to put off a lot of heat. Goes the receiver dryer, goes to the TXV, which is going to make it a low. And then right here, we have this evaporation that in the evaporator, that's going to absorb a lot of heat. Cool. All right. So basically what I'm saying is this absorbs heat and discharges it here. It absorbs heat in the cabin and it discharges it under the hood. What if we switched it up? What if we put the condenser behind the dash? And what if we put the evaporator under the hood? What's stopping us? Nothing really. I mean, So what if we had a system that could flow either direction? It doesn't even necessarily have to actually change the direction of flow, but what if we had a system where we could flip some valves and make the evaporator that's inside the car function more like a condenser and make the condenser that's outside the car function more like an evaporator? Then we could actually start moving heat into the vehicle. That's what a heat pump is. All right. That's what this does. This is a special pump and set of valves, and it's much, much, much more efficient than if we were to do electro-resistive heating or the PTC heating, or, now it can take a little bit of time. So sometimes we'll supplement it with some of these other heating types. But over the long haul on the trip, if it's cold, this is going to be the way to go. This is going to use a lot less energy, which is going to increase your range. On a hybrid vehicle, that's going to increase your MPG, right? But on an EV, that's going to it's going to lessen your watts per mile, increase your range, which is mostly what we're worried about on a battery electric, right? So the heat pump is this system, but modified, right? So this gives you just like a little bit of an overview. Normally, we would have hot air coming out under the hood and cold air in the dash, but we can flip it. So we'll actually change this valving. Okay. It moves. Now, this is a tricky term right here. It moves heat into and out of the cabin. It doesn't necessarily generate heat. So, like when it's a big electric heating grid, we're actually kind of generating heat because we're consuming electricity as a resistor to generate heat. But see, with this, we're really just we're absorbing heat from outside and we're depositing heat to the inside, is what we do. On a normal AC, we're absorbing heat inside and depositing it outside. But on a heat pump in heat mode, we're absorbing from the outside, putting on the inside. Now, they can work down to zero. There are even some that can work a little bit lower, but like for the general heat pump system on a vehicle, they'll work down to zero. If you're below zero, the problem is there's not enough heat outside to even be able to move the heat inside. So this is going to be a really bad design if you live in Alaska. This can only move heat. It can't really generate it. Make sense? So you're looking at one of the big challenges for these hybrids and battery electrics is in a cold climate, it's harder to make heat. It's than it is really to make AC. Like you can use this heat pump, but they're actually not quite as efficient as generating AC. So if you thought AC was expensive, try to make heat with electricity. It's very expensive. It costs a lot of watts to make the heat. Make sense? The best one we got is the heat pump, and that still costs a lot of watts. All right. So that's kind of what's happening there. You may need to diagnose these, but we haven't been having really tons of problems with them. However, I'll share with you the company that really is the main provider right now. Shocking turn of events. This would be Denso. Is just kind of showing you we don't want any cookies. How would I get rid of the cookies? Whatever. This is just showing you this is the system. It's the heat pump air conditioning system, and they're saying like this is the best. It was 2009 when they came out. It's got heat enabled at 10 degrees Celsius below the freezing point, so that's going to be fairly close to zero Fahrenheit. But if you look at this, it's just showing you it's still recirculating from the compressor. But if you notice something, normally the compressor sends it out to the condenser. But in this case, the compressor appears to be sending it inside to the evaporator. And first off, I'm using incorrect terms. And the reason why is because this may be the evaporator and this may be the condenser when it's in AC, yes. But when it's in heat pump, they're kind of reversed. So what do you call them? They just call it heat exchangers, right? So this would be the indoor heat exchanger and this is the outside heat exchanger. The room heat exchanger and the underhood heat exchanger. They're just heat exchangers. We can have it effectively flow and have the condenser really act like have the evaporator really act like the condenser. This will give off heat. It'll come over here and it'll absorb heat. It'll move back into here and it'll give it off. Okay, so now you can see a little bit about the heat pump. That's its job. And it's got a unique electric compressor with a gas injection function, and then the inner and the outer heat exchangers. It's got an expansion valve, but it's electric. And then a lot of times it's got a compact gas liquid separator. And they're not showing you all the valves here. They're giving you an overall idea of how this functions, right? And so, and this will give you a little bit more info, like how the compressor works, the liquid separator with the integrated valve. They don't exactly hold your hand on how it works, but what you as the technician mostly need to know is, hey, how does that BZ4X make heat? Well, a lot of it's going to have to do with the AC. It's going to use all the AC components, but it's going to change the valving to have it function as a heat pump to make the inside warm and the outside cool. They sell heat pump for homes. Very common. Not very common if you're in the far north though, because again, they just don't work that well when you get closer to that zero number. Make sense? They also sell heat pump hot water heaters, and they're much more efficient. California code actually requires that now. If you build a brand new home, you can't use a regular electric hot water heater. They say it's too inefficient. So you need to use a heat pump, which basically has a little condenser and a little evaporator, and the evaporator is going to be hot. It's kind of backwards, I guess. So I'm going to say the inside heat exchanger is going to get hot and the outside is going to get cold. So because this was so new, they had me put one of those in. When my hot water heater is running, if I go near it, the air next to the hot water heater is freezing cold because it's absorbing the heat exchanger is absorbing the heat into the outdoor heat exchanger, and it's putting the heat into the inside heat exchanger to warm the water. It's pretty trippy. Heat pumps are pretty interesting. But again, you need to be relatively surface level familiar with these. If there's a failure, you're going to revert back to DTC based diagnosis. Nothing to really be super intimidated over. And then again, remember in the heat pump, the refrigerant is what transfers the heat. Cool. High and low, all the same stuff that the AC does. Now compare that to if it's got an ICE. If it's got an internal combustion engine, that engine makes excessive heat. We run a cooling system to absorb the excessive heat. A positive byproduct of that is we got a bunch of hot coolant. So to make heat on a vehicle with an ICE is like a natural thing. It's like, hey, we already got to cool this engine. We got a bunch of heat. We got plenty of heat. We got all the heat we need. We can get your vehicle in Alaska warmed up nice and toasty, and that would actually kind of be nice for the engine because the cooling system is going to get rid of some heat. It's going to leave a lot more of a margin in case you're running like very heavy loads or higher horsepower, whatever. Like that's one nice thing about ICE. The cooling system is the heating system, but not on a battery electric vehicle. We need to generate the heat. Cool. Although I gotta admit this is pretty low efficiency. Cool. And then again, when we get into the heat pump, just remember it's less overall energy when coupled with an electric propulsion system. So if you're talking about this Tundra, can't make it unfuzzy background school computer. But if you're talking about this Tundra, if you were to add a heat pump system on there and run the AC to make heat, that's very inefficient when you got hot coolant pumped all over the place. We're just going to use that hot coolant. But when it's a BEV, we don't have hot coolant. It's the most efficient way we have to make heat. It's just the way it is. Cool. And we can get, again, it's a type of a scroll compressor, but it's just a little more efficient, right? And again, it's driven by the inverter. Okay. And then when we go to work on this system, a lot of times it's going to call for some sort of a POE or a ND11, specifically ND11 is a type of POE, but it's going to call for a specific oil. You're going to look on the sticker. It's going to call the oil out and that's the oil you're going to use. So for example, wax free, replacement for mineral oil, 4 times less hygroscopic, good solvent if exposed to mineral oil, releases debris trapped inside components, Uh, Keep the lid closed. So if you have the lid off, that's going to absorb moisture and it's going to be ruined. Moisture and heat can make it acidic, right? So just generally, we take care of this oil like we do any other oil, but it's less hygroscopic. One of the reasons that PAG oil is so conductive, honestly, it's hygroscopic, which means just like brake fluid, it grabs the moisture out of the air. If it grabs the moisture out of the air and stores it inside, you guys know water is kind of a decent conductor, right? So if the oil has a bunch of moisture in it, that's like water, it's going to become more conductive, right? So that's one of the reasons that the PAG oil, the POE oil is better for hybrids, EVs, less hygroscopic, less conductive as a result. Now, we talked a little bit about the hybrid BEV, but when we get more into the system, you got to understand the AC and the heating system is not just for you. A lot of times we'll do that for the battery as well. All right. So if the battery is too hot, we need to cool it. If the battery is too cool, we need to heat it. Right. So the HVAC systems tie into both. And that's one of the reasons that HVAC, is part of this class, or a hybrid EV is part of this class, is because all of a sudden our HVAC systems are being used for a lot of hybrid and EV battery stuff, right? The cooling system for hybrid and BEV control thermal conditions, right? So too hot, too cold, etc. They can have different electrical systems and components. So like, for example, we got the battery, we got the motors, we got the inverters, we got the actual AC compressor, right? So sometimes these are all tied in. A lot of times we'll actually heat or cool the inverter, we'll heat or cool the battery. We'll work with a lot of these types of things, but we definitely can't have overheating. Overheating is going to damage the battery or the inverter, but it can also lead to thermal runaway. You guys know what thermal runaway is? I mean, I'd call it a word with an F, but the manufacturers don't like that word. Insurance companies don't really want to hear that word either. Thermal runaway. Let's see. A thermal event, a a fire. I'm just gonna call it how it is. It's a fire, right? If we let this get too hot, that's a fire. Cool. So we need to keep them cool. There can be multiple systems. It can be a little bit complex, but one thing that's a bummer is the cabin can't be heated by waste engine heat, especially um, on a BEV because there is no engine. But even on a hybrid, a lot of times for this hybrid to be efficient, we don't have the engine running all the time. So it's kind of like when you start it up and it's in EV mode, the engine doesn't start until you're up to a higher speed. Like we can't use the engine heat because the engine's not running, right? So a lot of times we'll use a heating element. We're going to use electric current. It's efficient in some ways. Okay. And I'm going to clarify. To heat the whole entire cabin, not really. However, to heat just your body, for example, with a heated seat, actually that could be more efficient because you're only heating your body and you're going to have a heated steering wheel, right? Rather than heating the whole cabin with a heat pump. That could be more efficient, but actually resistive heating is not as efficient as a heat pump. It's just more efficient if it's localized. Okay, cool. It's going to use electrical potential from the battery pack. So yeah, that's drawn on your battery. However, well, there you go. It can decrease the vehicle range by potentially 40 to 50% in cold weather. So if you bought a battery electric vehicle and it had a range of 250 miles, you could probably get down with that pretty good. Most people aren't driving more than 250 miles a day. Better yet, if you have it charge at home, you can start every day with a full charge and never go to the gas station. It's convenient. However, you're not normally going to charge it to 100%. They like to be charged to 90, if not 80, right? So if at 80%, you're closer to 200 miles, and you never want to really run it all the way down. So at 200 miles, you don't have all 200 miles to drive. And then you get really cold out, and all of a sudden you only have 100 miles. And 100 miles would be if you're dead on the side of the road, battery discharged. So you're really more like 90 or 80 miles. And some of you do drive more than 80 miles a day. So you can see real quick how a battery electric vehicle is amazing until it's in cold weather, and then it can't even do your minimums. And then you're charging the car every day to maybe just barely make it to and from your destinations, right? So big problems with generating heat in a BEV. This is one of the biggest drawbacks right there. But if you don't have cold weather, good to go. All right. So when we get into the battery cell cooling, there's a lot of different designs. All right. So I actually cut some of it out, but we've got different plates and tubes and pipes, and we're coming up with different ways to try to keep all the individual battery cells cool and the same cool. Like we don't want to cool these and let these warmer, want them all universally cool. That's pretty difficult. So we could use cool air going in the battery pack. That'd be air cooled type. We'll come back with that. We could do a thermally cooled heat sink or cold plate. So that would be like there's a heat sink on the battery and some paste that makes it so the heat will leave the battery cell into the plate, and then we'll cool the plate. You know, that type of thing. If you think of how the heat actually flows, it goes hot to cold, right? And sometimes we could be using a liquid like a coolant, not water, but literally coolant, or even AC refrigerant will flow through there. There's different designs. Okay. So if we were to get into like some of the different types, we could actually run a full blown uh, HVAC, a full blown refrigerant system to the battery to cool it. We do that sometimes. If we wanted to warm it, we could use a PTC heater. So kind of what's interesting is we'll have a controller. So if we have the battery, we'll have actually a controller that's going to electronic computer that's going to control several things. We may have it control the coolant. We may have it control the AC. We may have all the battery temperature sensors report to the BMS, a battery management system, right? So like we'll have a computer that's in charge of maintaining temperature. If it gets too cold, it'll heat it. If it gets too hot, it'll cool it. If it gets too cold and we don't heat it, actually the battery's performance can go so low, it would have been more efficient to use the battery's power to heat itself rather than to let the battery go cold and discharge no power. It's kind of crazy, right? But the power will substantially diminish below 40 degrees, right? So if it's starting to get closer to that, we need to warm it up to not lose a lot of performance. All right. So when we get into the PTC heater, it's going to preheat coolant, and then the coolant's going to be circulated to warm up the cells. Cool. And then other times, if we have smart valving, sometimes we'll use the coolant and we'll have valves that'll send it to different places, you know, to do different things. So if we wanted to transfer heat from the drive motor to the battery, the drive motor may be getting hot, and we'll run coolant down there, not just to cool it. Like, yes, it's going to cool it, but we're really running coolant to the drive motor to get the heat from it so that we can pull the heat back into the battery to warm the battery. Right. So this is smart valving, is where it's going to monitor temperatures in the system, and it'll open and close valves to send coolant to the places that's going to benefit the vehicle the most. Maybe to the drive motor to cool it, but also to heat the coolant, then maybe to the battery to warm the battery up, which is also going to cool the coolant. So then we can therefore go back and cool the drive motor more, or et cetera. It can go different ways. And when we do that, it's going to reduce the PTC electrical load. So that means like pumping the coolant around to warm up the battery is more efficient than generating heat through electroresistive, current flow. So we could do it in several different ways, but that's actually a pretty efficient way. Now, when we get into the battery pack, there's going to be tubing. There's going to be literal coolant passages going through the battery. A lot of times that coolant's going to go in the battery and through the battery and around and do all over the place, and then have to come back out, right? So just so you all understand, there's seals, there's gaskets, sometimes it's sealant, and it's all got to be really well sealed and things. And that's coolant that actually has to be maintained as well, by the way. So yes, a lot of batteries actually have coolant flowing through them. Not all of them, but some do. Other batteries will have the refrigerant. So the TXV can actually route it through the battery pack and it'll actually literally go through the battery and cool it like a condenser, like there's a heat exchanger in there. Okay. That's a refrigerant based system. Other times it's a little less fancy and it's more like cold air, right? We'll come to that. Liquid cooled. That's a lot of times when we would use a PTC, positive temperature coefficient heater, to generate heat in, let's say, like a heat exchanger to warm the coolant, and then we'll pump the coolant into the battery. All right. So the PTC heater doesn't electrically heat the cells. The PTC heater heats coolant, which gets pumped in the battery, which heats the cells. All those pumps can fail. All those hoses can leak. All those connections can fail. All those gaskets can have problems, right? So that's why you need to know a little bit about it. And then we've got another type that it's very similar to HVAC, but this is a little different, right? So like these two are tied in with HVAC, especially refrigerant based. This one's like HVAC. It's got a blower motor. It's got ducting, but when the seats in the when the battery's under or behind the seat, a lot of times what we'll do, we'll have a little filter and an air inlet right here, and we'll have a blower motor right here, and that's just a 12-volt regular control blower motor, but you can't turn it on or off as the driver. The computer turns it on off. So when your battery starts to really move a lot of amps and it gets warm, it'll turn on the blower motor. It'll suck air through the vent and push air up through the housing. It'll go through the battery case and just air blowing across the cells will cool it. And it's not a bad system. It's simple. It's not it's not productive enough to work on a BEV, but it can work on a hybrid with an ICE. All right, so it's a good system, and yes, those blower motors need maintenance, and yes, those inlet filters need maintenance, and yes, we've seen them in this class cause the AC to blow warm periodically, and the car had been to two different shops and misdiagnosed several times with a whole bunch of new parts on it, compressor, several sensors. So if you've got a system like this and this battery actually starts to get too hot, think about it. The battery's too hot, it's going to limit the amount of current flow coming out. And if it limits the amount of current flow coming out, it's not going to make it's not going to cut power to the drive motors first. It's going to reduce the power going out to the AC compressor, because remember that the inverter drives the AC compressor, but the inverter gets its power from the battery. Makes sense? So if our battery's overheating, all these different various modules will limit the amount of energy leaving the battery in an effort to cool it. And the customer's concern is, well, the AC blows warm sometimes, and it may be literally as simple as the filter for the air inlet for the air cooled battery is dirty. All that was over a dirty filter that could have just been cleaned. But you got to be familiar with the system. So the group that did that, they did great. They did amazing. But that's why I want to include this. All right, cool. So when we get in the air cooled, there's a cooling fan, there's ducting, there's sensors, a lot of times air temperature sensors, and there's a computer control module. And sometimes we have different types of heating. It's air cooled, but a lot of times it can be a combination. And if it's a hybrid, air cooled is good. If it's a battery electric, not going to be the case. So like, here's a limitation: uneven cooling. Um, it will result in higher ambient temperatures. It's especially not good in higher ambient temperatures. It's only going to cool the battery as much as the air is cool, right? So if it's hot and the AC is struggling, or there's a lot of passengers, its cooling effectiveness is going down. Cool. And then it's if you have the air cooled system, that'll a lot of times mean it's an air heated system. And so it's hard again to really generate a lot of heat through air cooling and air heating. But we do have some, and it can actually potentially cool quite a bit if it's a cool day. but on a hot day, it's going to be pretty minimal. All right. And it's also going to add to the heat in the vehicle. So that's the thing. You're pulling cool air out of the cabin. So we can't even use all the cool air out of the cabin because then the cabin's gonna be warm and the customer's gonna complain, right? So it's limited. If it's a battery this size, it's fine. If it's a big battery, not so much. It's a big battery, we're gonna go liquid, right? Just rough estimate, if it's air cooled versus liquid cooled, a lot of times liquid can move 4 times the heat energy per volume, right? So like the easiest example I can say is intercoolers. Ooh, now you're excited. An air to air intercooler that's this big would be the same as a liquid to air intercooler that's this big, right? The liquid cooling needs 1/4 of the surface area. Now we're not going to give 1/4 of the surface area. We're going to give a bunch of surface area, which really means it's going to provide up to 4 times the heat transfer. The liquid cool is going to be much more effective at moving big volumes. We're going to again move it to the ambient air, but we're going to move it outside. So if the coolant is cooling the battery and then go into a heat exchanger outside, the customer's not like, oh, my cabin air feels warm. It's outside. All right. But again, another part of it, we'll use flaps. A lot of times we'll use like shutters, you could say. We'll actually cover them. I'll show you a picture. But when we get in this liquid cooling, we can't, we don't necessarily want to overcool it. So a lot of times we'll have ways to restrict airflow, shutters, so that we don't get too much cooling. Okay. So when we get into those um, different valves and things, just keep that in mind. Okay. And yeah, we're going to use coolant. Like it, a lot of times is specific to hybrid, but it's it's coolant though. You know, it's the same type of coolant that a lot of times we'll use in a hybrid engine for the inverter. The inverter coolant a lot of times will be what also cools the battery and heats the battery. And keep in mind, if we have cooling system failure, that might be due to improper maintenance. If we had a failure that can get the battery too hot and even potentially lead in thermal runaway, we might have a cooling pump or a sensor failure. It could even just be a simple coolant leak. So if we have a hose that goes to the battery and the hose is leaking, it gets low on coolant, it could result in a totaled vehicle and a battery fire. All right. So if we get into this battery is overheating, type of issue, it might just be literally as simple as check the cooling system for leaks. It might be low on inverter coolant, which also cools and warms the battery, right? And there's another type of cooling, which is the heat sink, especially for insulated gate bipolar transistors. We've got transistors that are going to make a lot of heat, and we're going to have them contact a heat sink. And the heat sink, a lot of times they'll have paste and, like a good heat transfer paste. The IGBT will get hot and it'll actually transfer its heat through the paste into a larger piece of aluminum. And the larger piece of aluminum it is, the bigger the heat sink is. So LEDs, we do this with electronics as well. So if it's just IGBTs, it may not make a ton of heat. The battery itself may make a lot of heat, but if we're just trying to cool the IGBTs, like in the inverter, a lot of times we'll have those IGBTs touching this heat sink, and then we might even have some air, some fins, some coolant, or some cooling fins, but sometimes what we'll also do is have them go to a heat sink, and then we'll run coolant into there, which is pretty typical. And the coolant will cool the heat sink, but just understand the coolant's not cooling the transistor directly. The coolant's cooling this heat sink plate, a cold plate, and then the heat is transferring from the transistor into the cold plate. Cool. So it's still liquid cooled. That's how we liquid cool an inverter. All right. Now talking about the shutters. Oh, active grill shutters. Remember back here, we were talking about, hey, when we do these liquid cools, a lot of times we'll have to do a shutter system. Well, this is why. If this heat exchanger part of the radiator is for the inverter or for the battery, and let's say the battery's too cold, we don't want airflow to go through and cool it even more. So what we'll do is we'll actually have shutters, and the shutters a lot of times will be computer controlled. They're pretty much all computer controlled. And if the inverter coolant and the battery coolant is too cold, it'll actually close the shutters. And closing the shutters will restrict the airflow, which will actually allow them to warm up a bit, especially critical in colder days, colder climates. All right. So if you see shutters, just know that's what they're for. Because the airflow that flows under the hood can account for 20% of the air at the front of the vehicle. Now you'll notice sometimes on hybrids and EVs, they don't have big grills like this. And that's because a lot of times we don't have a big heat generating engine in the front, but we still have radiators. They'll be smaller, they may be a little bit lower. A lot of times they put them in the fender liner, in the wheel wells and stuff, but just know there's going to be a shutter system. If it's cold, it's going to close the shutters. That's part of AC and part of hybrid. But wait, there's more cool stuff. How about an ozone reducing radiator? That's kind of interesting, right? This looks like a radiator, but it's coated in a catalyst that's going to take ozone and convert it into oxygen. So that's pretty neat, right? They can actually get credits by the EPA. So if a manufacturer does this, the EPA will give them credits, for like better emissions vehicles. If you have a super a LEV, a low emissions vehicle, and a super low emissions vehicle, a super ultra low emissions vehicle, right? They can actually lower the emissions, not by lowering the emissions, but by putting in an ozone reducing radiator, which cleans up emissions. Makes sense. And that is balanced out in the equations. Kind of interesting. So remember, this is emerging technology now. That's how it works. Ozone comes in, it interacts chemically with this catalyst. Oxygen flows out. The air is actually cleaner than before it flowed through that radiator condenser. Cool. Kind of neat. Another thing we've been doing is a metal foam heat exchanger. So you'll have, like, for example, maybe in the evaporator, they'll actually do like a foam, and they'll inject a gas, especially in the molten aluminum where it forms pockets. And so there's little air pockets in there. It's almost like a spongy porous type of thing. Well, the thing is, when you're running hybrid, if you think about it, or even if it's a start stop, the evaporator's nice and cold. And then when it goes into stop mode, the engine stops running and the AC is going to start to get lukewarm. Well, in this metal foam heat exchanger, the pockets allow for uh, basically more heat absorption. So if you think about it, the way I would say it is like the air pockets are going to keep it cooler longer, right? So if it keeps it cooler longer, that allows for the start stop at the intersection to stay stopped longer before the AC starts to blow warm, in which case it'll automatically start. And it'll do that based on the evaporator temperature sensor. So if this technology helps your evaporator stay cold, that'll be reflected in the temperature sensor, and it'll be longer before your engine starts. Why is that better? Better MPG, lower emissions. That's the game, right? So sometimes they have a special phase changing wax type material that's embedded in the evaporator core to retain the cool temperature. So we could consider this a phase changing evaporator, right? So it's kind of like metal foam, except we've gotten even more advanced, and we're literally waxing them with a special material. And when we get it cold, the wax can recharge in less than a minute. But then when the engine's off, it takes longer, for the wax to cool off, and it'll actually keep blowing colder. And it can do this cycle an unlimited number of times. And it looks kind of normal, except it's got a special wax material. All right, so kind of fun. And another tech is called an ejector cycle system. And this is to the technician, it's the same. I mean, even this, like we change it, and it's like, oh, this is a weird evaporator. We change this one, and it's like, oh, this is a weird. To us, we're doing the same type of service on these, but it's important that you have a clue as to, like, well, what is this term I'm reading, right? How are the hybrid and EVs different? I'm showing you some of the technology, but the service is kind of the same. All right. So the ejector is a fluid pump and it uses some of the wastage energy from the refrigerant expansion, converts it into pressure that's used to circulate the refrigerant. Interesting. So it's going to be two different evaporators joined with a specifically designed pipe that allows for siphoning type action to circulate refrigerant through the secondary, which the main goal, lower the workload of the compressor. And then the temperature of both evaporators combine and becomes the temperature of the air sent. All right, so hold up. We've got like a doubled up evaporator. So the refrigerant's going to go into one, and then it's going to use the ejector cycle to kind of like siphon it through. And it's not going to make the compressor's job any harder. It's just the ejector design is going to push it through the secondary evaporator, and that's going to provide extra cooling. Okay. To us, it doesn't really matter. You're just looking at this evaporator and like, it almost looks like a double and it's got a weird valve on there. Yeah, that's just the ejector cycle. Not a real super big deal. Why do we want it? Well, if it is a decrease in power consumption, why is that so critical in a hybrid and EV? If it's on a hybrid, better MPG, lower emissions. If it's in a battery electric vehicle, there's no emissions as long as we don't count what it took to manufacture it, but in the day-to-day operation, there's no emissions. So we're really just increasing the efficiency, which means less watts per mile and better range. That's the big one, right? So if we use this in a battery electric vehicle and it increases the range, boom, it's a win. That's what we're after. Cool. All right. And then again, as we get further and further into hybrid EV, it's going to evolve, right? So just so you know, there's a lot of times the combustion side, the engine, the ICE, and one for the hybrid side. You probably have seen that. Maintaining battery temperature is extremely important for that, the long life and the productivity of the battery. But I'm telling you what I know July 2025. It's going to change, right? And that's why I really like to source a lot of the material, because when it changes, you got to stay up to date on it, right? So one of the next things when we talk about the ejector cycle, again, I'm pulling information from Denso. Denso came out with this saying, hey, we came up with this ejector cycle, and this was back in 09. And this was mainly made for the Prius, right? And it's saying it's going to decrease the power consumption, and it looks like this, and it's like a doubled up evaporator with this ejector valve, And so when you hear these terms, the ones I'm showing you now, I've tried to prepare as much as I can to help you understand them, but this is something that's going to change, and it's going to change quickly. Like the idea of a heat pump in a car was crazy 10 years ago, and now it's the norm. But wait, there's more. Um, Now, when we especially start to consider in colder climates, we can drop the vehicle range by 50% by trying to make heat. That's when we got into that heat pump. And so this is more just summarizing. We're using the heat pump to have little effect on the range, but it still has some effect. And then the generic explanation is we're going to reverse the flow of the refrigerant. Right. So the evaporator that was cold is now the condenser that's warm, and the condenser that was hot is now the evaporator that's cold, right? So that's just making sure you understand this is the main workhorse for your BEV, for your battery, for your EV, and even for some of the high-end hybrids too, like the Prius Prime will use this. This is your main workhorse. Cool. But that's not the only thing. So sometimes, like if it's a hybrid, we make heat when the engine runs. Well, that doesn't help us the next day. Well, unless we have an insulated container, right? So on some of those older Priuses, we had a container that looked like this. I call it the thermos. If we ran the Prius engine yesterday and we kept this in a highly insulated thermos, it might still be warm the next day. So they did actually have this. When it was warm enough, it opened up a valve and refrigerant would go into this thermos and it would pressurize it, and it would then close the valve and keep it hot in there because it was so well insulated. And then tomorrow morning when we start it up, boom, the valve will open. It'll let this hot coolant go into the heater core, and that'll help us to defog and defrost the windows and help us toast our buns on that heater. Makes sense. So this was another design. Although this is outdated, they actually haven't been using this for a while. It was a cool thing back in the day. Cool. Now another thing is called a TED, a thermal electric device. This is pretty current. Like for example, a AC compressor running in heat pump mode can use about 4,500 watts of power. If we were to use a TED, that could be like 600 watts per occupant. If you run the full heat pump, you're heating the whole cabin. That's kind of inefficient. Even though watt for watt, it's pretty efficient. To heat the whole entire cabin, if there's only one driver, it'd actually be more efficient to use a thermal electric device at 600 watts just to warm you. And the passenger seat is cold and the rear seats are cold, and that's fine. Okay. So sometimes they call it a Peltier device. It's solid state heat pump constructed of many semiconductors. This doesn't have a condenser and a compressor and evaporator and hoses and refrigerant and stuff. It's solid state. It all happens kind of like a transistor. It is a semiconductor. It can flow and not flow, and it's a very efficient method of providing heat, comfort. Okay. So if we apply voltage, the other side of the semiconductor produces heat while the other side absorbs heat and becomes cooler. So one side will be cooler and one side will be warmer. It's an interesting device. We can put them actually near the evaporator as well. So this is not necessarily a PTC, but it functions similar to a positive temperature coefficient heater, but it's more expensive, but it's much more efficient. All right. Now, if you were to have TEDs in specific points, you see you could actually put a thermal electric device here for the passenger, here for the driver, here for the rear, right? And I don't think that they're doing this on very many vehicles. They're not really using a lot of TEDs, but we do use radiant heaters, right? So if you're thinking the HVAC system heats the whole cabin, cool. But what if you were to just make the person in the seat warm and not necessarily worry about heating all this air? Again, we're going for efficiency. This could be more efficient. So for example, this is the BZ4X. You can actually turn on a radiant heater. If you go ahead and a lot of times this will come on if you put on auto, by the way. A lot of times the default is auto, put it up to the temperature you want, 70 degrees. The HVAC ECU is going to start doing what it thinks it should do to make the customer comfortable without necessarily with saving as much energy as possible to not kill the range. Okay. So a lot of times you put it on auto, it's automatically going to do it. But in this case, you can actually control the radiant heater, and that radiant heater will warm you separate from the traditional HVAC system. Okay, so I made a link so I can show you. Like always, Toyota's mad. All right, bring this over here. And again, I'm pulling a lot of stuff from a lot of different places because these are things that change very rapidly. I didn't really save it, but that's okay. We'll do the BZ4X. We'll do a 2024. We'll do a Radiant. We'll just type that in. And there was quite a few failures on these for the record. It's a new tech and they're still kind of trying to figure it out. So if we were to look at new car features, I actually probably wanted general. All right, so look, it's gonna tell you all about, depending on what the vehicle spec is, it's gonna generate heat. And look, it's right here under the steering column and right here kind of near the glove box. And when they run these, it'll make your legs feel warm. That's what they did some research, and they found a lot of times if you can warm people's legs, like right around their knees, can actually make you feel quite a bit warmer. So they put these in and they're radiant. So it won't heat the air. It'll heat your body directly, right? Kind of like the sun's radiation. On a cold day, if you go outside with a black t-shirt on, you can feel the heat on your black shirt, but the air is cold. That's the radiant heat. So we use heaters like this. They are actual devices in there. So if we were to look at this, This is the device. Looks like a plate. It's got circuitry inside, right? Here's how you control it. Can tell you, you can put it on auto or you can turn on and off, right? Gives some information. So we're using those radiant heaters. It's an addition. It's mostly something that you're going to see on a hybrid EV, most likely probably an EV mostly. But you know, it's a nice little addition. A lot of people don't even know we're doing that. And then when we get into like driver specific ventilation, sometimes, you know, for example, like a cooled seat, it's actually more efficient to just try to cool the area right where the driver is. We're still cooling the air, but it may potentially close off vents and try to cool the driver. Or if it's in the case of like a cooled seat, you know, we're just going to try to keep the area right where the driver's sitting nice and cool, especially like all up in here. And when we get into talking about heating and cooling with hybrids and EVs about efficiency, the seats make a lot of sense. So you're going to find a lot of the electric vehicles are going to have heated and cooled seats because it's more efficient to heat your body directly than it is to use the same type of heater to heat the air, to blow the air, which loses some of its heat when it gets to you. Just heat it right here. This is one of the most efficient ways. So if it's an EV, especially, heated steering wheel, heated seats can be very common. Very, very common. Now, when it gets into cooled seats, a lot of people don't have all the facts here. The cooled seats do not have their own compressor. They don't have refrigerant flowing through them. They're not really doing that. What they have is ventilation, and they'll have a blower motor inside, and that blower motor will pull air from somewhere. A lot of times they'll pull air right from the bottom, and a lot of times there will be ducting from the regular AC that go through the console and under the carpet, and it'll actually have regular HVAC cold air ducted into the seat. And when you turn the heated seats on, it'll have a blower motor that'll push air through these little perforations, which I'll show you, and it'll be it'll feel cool. It'll be just like AC, but it doesn't have its own AC. It's basically robbing cold air from your regular HVAC system, right? So don't don't think it's any more than that. All right. It's really just a ventilated seat that happens to pull air from AC. Now let me show you a little bit about that. If we were to go with you know, we'll stick with the BZ. Go with the 2024. Let's do it the heated seat for a quick second here. Now, I think you guys all know how this works, right? You're going to push the button and that's going to adjust the heat, medium, high, low, medium, or high. But what I really wanted to do is if we're diagnosing these, that circuit's monitored. If we have a failure in the circuit, a lot of times it's going to set a DTC. So this is the front right seat heat sensor circuit, short to ground. So this is the sensor, right? If you get an error with the heated seat, a lot of times it's just DTC diagnosis. You can put the DTC in. It's going to tell you, here's the circuit overview. So we got the AC amplifier, and the AC amplifier is going to basically control sending heat to the right hand cushion to the left hand cushion, or, you know, it'll control the right hand cushion using terminal 12 and the left hand cushion using terminal 3, or actually this is the sensor. So that's not the heating element. That's actually a thermistor. If you remember, we covered thermistors. That's a temperature sensor. So if we wanted if we wanted to know what temperature the seat was, we do a temperature sensor. It's going to monitor that, which that makes sense because I did accidentally click the sensor. These are heat sensor, heat sensor. Yeah, so that makes sense. If we were to look at terminals of the ECU, we could see that it's got the heated seat systems. Here we go. This is going to be more helpful. So we got the AC amplifier, which is kind of like the HVAC ECU. The front heat seater switch, we're going to press that. air conditioning control assembly sees the signal from the switch. It's then going to communicate that. And this double line right here is LIN. It's going to communicate that on LIN. Is it going to be like that on all vehicles? I don't know, but that's how it is on a 2024 BZ4X, right? So even some of these systems, I don't know the details on, but I'm showing you how you'd learn about them. Right? We're going to access it and be like, oh, okay, so that's how that works. So if you're pressing the heated seat button and it's not working, you'd probably go into your live data, look at the air conditioning control assembly, push the button and see if the live data shows pressed, released, right? That's how you're going to diagnose the switch. You could also most likely active test the AC amplifier to apply heat to, let's say, the left front seat cushion heater, right? So we could apply that. If we command it on with active tests, we should be expecting 12 volts here. Now, this doesn't have terminal numbers or connector end viewer in it, but that's all right. You're getting educated on how the system works. It's going to probably apply 12 volts. It might even be like a duty cycle. But we know that if, let's say, we command it on with the with TechStream GTS Plus, and let's say that we get 12 volts here, but we don't get 12 volts here, that would be like a wire. Or if we do get 12 volts here, we know that it's the heating element. Now, if you needed to know exactly terminal numbers and stuff, that's when we get more into the terminals of the ECU. That's when we actually might pull the EWD, right? That's when we can start to see what the actual measurements should be, right? So you guys can see it's electrical diagnosis. It's just specifically with regard to heated seats. Now, if I went with a ventilated seat, it's an interesting concept. Let's do I think I did search this. I mean, there's not really a ton to do. I think it's a cooled seat or a ventilated seat. Let's take a quick look. Let's see. Water cooled condenser. No, but that's interesting. All right, this may not actually have ventilated. Let's see. All right, climate controlled seats. Oh, yeah, it does. All right. So there's your confirmation right there. Yeah, I looked at this earlier. Depending on which model, if it's a cheap model, it may not have it. But if you look, number 2 is seat cushion climate control blower assembly. That's a little fan, little blower motor. And that's going to actually pull air up from the bottom and send it through the perforations. And then the seat back has its own little blower. Right? It's just the way that's going to work. Kind of interesting. Cool. So nothing real crazy on that. All right, kind of fun, but wait, there's more, I can assure you. Because let's just say you really loved really clear air, really clean, nice air. Did you know that some systems have things like an ionizer? So like this one's Kia, for example. You know, we have cabin air filters. If you have a nice cabin air filter, it's clean. If you have a really nice one, it's got, carbon impregnated in the fiber so that it reduces smell. If you're really a big baller, you can get a HEPA filter. Well, Kia does something interesting because all those filters need to be replaced. Kia does one that's a ionizer. So we're going to use electrical power to ionize this. So it's going to release positive and negatively charged ions to neutralize odors and smells. So that's interesting. We can also ionize the air by releasing negative ions that will attract very small particles of particulate matter in the cabin the filter can then remove. So it can basically like pull the particles in, and that's a good way to clean it by charging it with negative ions. Right. So we're actually cleaning this air extra by using this. Actually, home air purifiers do this a lot. So they just took a note out of the home air purifier book. All right. And then in addition to, not to forget, we still have the whole rear HVAC box. So when we talk about emerging tech, We could even get into the there's different ways, different things we could do with this. But if we have the rear AC system, this is overall to give you a view for what I'm about to show you right now. We've got, an evaporator in here. We've got a heater core in here, but it taps into the same condenser, the same compressor, the same coolant pump, right? So anywhere we wanted to mount another heater core, we could heat stuff. Anywhere we wanted to mount another evaporator, we could cool stuff. Now, if it's a van, we're cooling little kids and stuff and pets and whatnot. But this is the rear AC unit. So to give it a good overview, make sure you understand. Now, part of the reason I brought this up is because I got an interesting thing to show you that not a lot of people know about. So we're going to pick a pretty cool car. How about a Lexus? How about a GX? I think the 470's got it. Oh, it's a 60. 460, 2023. And let's do cool space box. And you're like, what the heck is that? Let's jump in new car features. Let's check right here. And I think this will most likely work. I think the 70 has it. No, that's too much about the specs. System diagram. Okay, looking good. All right. Yes. So here in this system diagram, it talks a lot about, all those communication things and normal stuff and solar sensors and the control and the dampers and the whatever. And then you're like, what? The cool box amplifier, cool box switch. Wait a minute. The what? What the heck is a cool box? Only models with the cool box. All right. So let's take a look at this. Okay. Uh-huh. Uh-huh. Okay, rear AC. See where we're tying this in. So it's got rear AC, it's got a rear evaporator. What the heck is that? Models with cool box. Center console has a button that says cool box press. Huh. Well, I'm gonna tell you. They add an evaporator down here, and if you run this, the evaporator will cool this area right here. So what are you gonna put in this cool box? Come on, this will get you excited. What are you gonna put in there? Huh? What you want to put in there? Hmm? Well, that's where you're going to put your beverages. So you can literally put your cool beverages in there. All right. So if we were to look, right, you can see how a lot of the system goes. Uh-huh. Uh-huh. There's the controls. All right. Cool. 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 Interesting. Very good. Talks all about the compressor. But then you'll notice this has a much more complicated system. So you got a compressor right here. That compressor is going to go to number one. Number one's the condenser. All right, cool. Then right here, it can either go this way or this way. So if it turns right here, that's number 8, a cooler expansion valve. Say what? Which is going to flow into number 4, number 1 cooler evaporator subassembly. Interesting. So the number 1 cooler evaporator subassembly. All right, so what I'm telling you is this is an evaporator. And then down here, this is another evaporator. So it can have how many evaporators? 4, 5, and 9. 4, number 1 cooler evaporator. 5, number 2 cooler evaporator. And 9, rear evaporator subassembly. You got 1 condenser. You can have an evaporator for your front AC, an evaporator for your rear AC, and an evaporator for your cool box. and the cool box can keep your ice cold beverages. Make sense? So this is just a extension, really. It's very similar to diagnosing rear AC, right? But the way that you turn it on was it showed you in that previous picture. Just press the button. If you just press the button right there where we saw it, it was here. If you press that button on, it's going to automatically change that valve and start directing refrigerant back there into that cool box. All right. So just so now you guys know, cool box is a pretty nice feature. They even have them on like a LC 500. So you can have like a V8 5.0, really nice curvy bodied vehicle that looks like a sports car, but then have your cold beverages in your cool box, with your favorite color of structural blue that actually has no blue in the color, but it's the most blue thing you've ever seen. They got some really cool stuff, okay? But wait, we're not quite done. So that's a little about the cool box. Whoops. This accidentally jumped back to way too far. Here we go. All right, cool. And then the last but not least, and I would say last but not least, is when we get into some of these higher end EVs, they can do really cool stuff with HVAC. So, for example, this is the Model S. There's a button right here you can see. Do you see that thing at number 12? That's called bioweapon defense mode, literally. So when you push bioweapon defense mode, it actually runs the AC on max and it moves the doors in such a way where it'll try to recirculate and build as much pressure as possible. And if it builds as much pressure as possible, any little bioweapon that might be coming in the nuclear fallout, should be kept out of the car. And it's also going to run maximum through a HEPA filter. It's actually a fully like HEPA, like almost like a respirator type of filter. So like the other day, I thought it was pretty neat. We were out running around near Oceanside and there was a big fire. You guys can fact check my story, but there was all of a sudden a fire at the airport and we were like right on this road that goes right next to it and it was super smoked out. And I was like, let me put this in bioweapon defense mode. Hit that button. You couldn't even smell the smoke. I mean, it was pretty incredible because it was not only pushing air out to kind of keep the smoke out, but it was also running through the HEPA. It was like, man, this is pretty awesome. So pretty cool, but that's not it. If you look right here, we got a few things. We can schedule the AC to automatically start or schedule the heat to start. So let's say you get out of work at 5 o'clock, slacker. You could be like, hey, at 4:55, crank this AC up and you come out to the cold car every day. Or let's say that you go and you park someplace and you're going to run inside to do something and you want to keep the car cool. You just press keep and you can go in, the car will lock, the car will look like it's shut down, but the AC will maintain or the heat will maintain. Or let's just say you're camping, that'll basically do kind of the same thing, except it'll run like all night. Or let's say you put it in dog mode, you got your pets in the car. Don't judge me. Now that some of you got to meet George, she's a little crazy, but she's sweet once you get to know her after she bites you. If we, first off, I don't really leave dogs in a car, just FYI. But if we had to, and I put it in dog mode, I could put it in dog mode. Well, that's not true. One time I brought my dad somewhere and he had his dog and I was like, we'll keep him in the car, set him up with a bed, push dog mode. On the main big screen on the Tesla, it says, I'm in dog mode. My owner will be right back. The interior temperature is, and it shows the temperature live, right? So if you came up to a car and you saw, and it was hot and you saw a dog in there, you'd be like, I'm ready to bust that window out. When you look in, it says, I'm in dog mode. This is the temperature, right? It's made so that, people don't bust your window out if you do leave your pet. So these are some of the cool functions. And I'll actually show you a little link to that, which I did save. Oh, this thing got a little bit mad at me. The link didn't work off screen. The link will work on screen because again, this is this is information that you'll need as the features and stuff change. But like Tesla, for example, has all free service info, right? So this will give you an overview. 12, for example. Remember I mentioned 12. If your Model S is equipped with a medical grade HEPA filter, This filter ensures the best quality and et cetera and et cetera. Um, it's effective at removing particles, pollution, allergens, bacteria, pollen, mold, viruses. The HEPA and the secondary filter also contain activated carbon to remove a broad spectrum of odors and gases. I mean, if you put it in bioweapons defense mode, the positive pressure inside the cabin maximizes the amount of outside, minimizes the amount of outside air that can enter the vehicle. That's a pretty cool mode, right? So that's some of the most advanced HVAC I know of. Then, of course, um, we could jump in and say, learn about the keep and the dog mode, but I already kind of explained those. And then, of course, on this one, you can use voice commands. So you could just press the button and say, turn down the AC or put it in dog mode or whatever. If I really wanted to, additionally, control it, as some of the more advanced systems, you can do things like this. Here you go. It's warming up right here. I think you will be able to see this. No, if not, that's okay. I have a fix. I'm gonna stop the share. I'm gonna flip my video right here. Okay, here we go. All right. You should be able to mostly see that. If I want, I can go here and it'll literally start running the AC. I'll put it on climate right here. If I want, I can, you want to do heated steering wheel? That might be fun. Here, let me back up a little bit. Right. So I can check the temperature of the car right where I'm at. I could open and close the windows. It'll tell me the interior and the exterior temperatures right there. I can put it in different modes. I can put it in dog mode. I can put in all this type of stuff. But there's one I want you to see. What do you think cabin overheat protection is all about? Why do you think that's critical on an EV? Anybody got any ideas? Battery. So if the cabin starts to get too hot and that's linked to the battery or if various electronics, it'll actually never let the temperature inside the cabin exceed 100. Now, a lot of times you can't control what it's doing with the battery, but if your battery gets hot, it's going to automatically keep it cool. Well, if I let the charge go too low, it'll be mad at me and it'll say it can't keep the cabin temperature or whatever. But what's kind of cool about some of these EVs is, if it has this feature, that cabin has never exceeded 100 degrees. That's probably going to prolong the interior and the materials and the dashboard and whatnot, because even if you leave it out in the sun, this will automatically start up and keep stuff cool. Now, the negative is, yeah, if you go to the airport and you park your car on the top level and then you leave it for a week, it's going to be dead. It's going to run and run and run and run and run, right? So I'd actually probably have to turn it off if I was going to take it to the airport. But some of the more neat features. So before I forget, I actually need to turn that off because there's no reason for me to be running that, right? But just to show you some of the more advanced stuff, pretty neat, pretty cool things. All right. So if you guys will let me just switch the camera real quick. If you got any particular questions, shoot them.